In this video, we're going to make a specific target pH with a weak acid-base mixture. So we're going to use acetic acid vinegar. The Ka of vinegar is 1.8 times 10 to the minus 5, and we want to make a mixture with a pH of 4.35. We're going to make a liter of it, and we're going to do it by using 0.25 molar vinegar, and we're going to just sprinkle in sodium acetate. So we're going to add solid of the counter ion of the conjugate base until we've added enough to adjust our pH. End goals then, well, how do we do that? What's the mass of the sodium acetate that we need to add to this liter to make this pH? How we go about this kind of problem is we need to know how much of the acetate is required. If I just throw pure acetic acid into solution, you'd end up with a solution that has a pH of 2.37. We've calculated it before, but you can run the pure weak acid calculation if you like. Well, that's well above what we want. So somehow we have to bring this pH up, make it more basic. How do we do that? We add base. How much base is required? Well, set up our reaction. Our HAC is going to break apart into H plus and AC minus. Now, normally when we have a pure weak acid, we would put in our starting amounts, which if we have 1 liter of 0.25 molar is 0.25 mole. And then we'd have none of our products, but that's not the case. We're actually trying to have a very particular amount of H+. So instead of seeing how much H+ would form if the pure fell apart, we actually want it to be a certain amount and then solve the acetate that would make that happen. If my pH is 4.35, that means the concentration is 10 to the negative 4.35. Remember to turn our pH into H+ concentration. I want a set amount of H+. I want it to be this amount. So what the heck does my acetate need to be to pull that off? And so we're not looking at the dissociation amounts, we're looking at the necessary concentrations of each component with the ones that we want set plugged in, solve the unknown that makes these true. Remember, our Ka, our equilibrium constant, is our H+, 10 to the negative 4.35. Some amount of acetate, and a known amount of 0.25 moles per liter of the vinegar. Well, Ka is 1.8 times 10 to the minus 5. So if I want these two values, my weak acid and my H+, to be these values, X is what I have to adjust to make this true. X either needs to be large or small. It needs to be some number so that when I multiply these, it equals the equilibrium constant. What amount of acetate is going to make that happen? Well, rearrange, multiply the acid up, divide the H+ down. 1.8 times 10 to the minus 5 times 0.25 divided by 10 to the negative 4.35. All that has to equal the acetate. So for these set values of starting material and target pH, what amount of acetate would make that be true? What amount of acetate would make the equilibrium balance out here? 1.8 times 10 to the minus 5 times 0.25 divided by 10 to the negative 4.35. What we find is that is 0.1007. I need 0.1 molar. A mixture of 0.25 molar vinegar with 0.1 molar acetate will give me a pH of 4.35. So I know how much acetate I need. Well, the second part of this problem is, where do I get that acetate? I get it from adding sodium acetate. So I need to figure out how much sodium acetate I would need to add to this bottle for this to work. So I need, well, this is in 1 liter, so 0.1007 moles in 1 liter, and I'm in 1 liter, so I need 0.1007 0.1007 mole of acetate. It's 1-to-1 with my sodium acetate, so I need 0.1007 mole of sodium acetate. My sodium acetate, well, 1 mole of it weighs 82.03 grams, so we can calculate out what weight of sodium acetate I needed to add, which was 8.26 grams. So to our 1 liter container of 0.25 molar acetic acid, I would need to add 8.26 grams of sodium acetate. Every little bit I added would adjust my pH. It would have started at 2.3 something, sprinkle a little sodium acetate in, it'd raise it a little bit, sprinkle a little bit more, it'd raise it a little bit more. Add sodium acetate until I added 8.26 grams, and it would have raised it to 4.35. To calculate out how much of one of the components of a buffer is needed to set a particular pH, we need to simply use the equilibrium expression. The difference is, instead of looking at the partitioning of our pure substance into the products, we actually have some of our products already set. So we are simply plugging in the known amounts to our equilibrium expression and solving for the missing component. What does that other component have to be so that the known amounts that we want will still be true in the equilibrium expression?